We have two big ideas that we're going to tackle today. The first one is the word and. What happens when you have two events that happen similar to what we left off with here? So let's talk about this. In the morning, you're getting ready for school and you're late, so you choose clothes randomly. Let's say you have one pair of jeans and one pair of khakis. You also have four shirts. One's blue, yellow, green. So what's the probability if you grab one of each? The probability you get each one of those things. Well, if you can start our little tree, the first thing we can do is either you can put on your jeans or you can put on your khakis. And then after that, you can grab one of the shirts. Okay, so if we're doing this, you can either have blue, blue, yellow, green, or green. Same thing here. We can have blue, yellow, or you can have green or green. So hopefully it's clear there's 8 different outfits that we can have, jeans with each one of those and khakis with each one of those. So if you want to find the probability, what's the probability that you choose blue jeans with a blue shirt? What do they call that, a blout fit or something? You got your jeans with blue. Well, that's 1 out of the 8 possibilities, so we have a 1/8 probability. Jean with yellow, same deal, 1 out of 8. Jean with green now, there's actually 2 out of the 8, so you have a 1/4 probability. Well, these are pretty easy, and you can fill it out for each one. But is there a different way that we could do this? And the answer is, yeah, there is. First of all, you can take the probability of the first event, which is jeans, which would be 1/2. And then you can take the probability of grabbing the blue shirt, which is 1/4, and you can multiply those. 1/2 times 1/4 is 1/8, and it works out. So similarly, if we want to do jeans with green, the probability that you grab jeans is 1/2, and the probability you grab a green shirt is 1/2. Multiply them, and you get 1/4. So it's a different way that you can calculate probability. When you have an event followed by another event, so 2 things are happening, we're going to use the and down here. And the symbol we're going to use is an upside down little arc like that. We're going to read this as and. It's called the intersection. That's another way to think of it. The intersection. In a bit, we're going to talk about Venn diagrams. If you have Venn diagrams, that's where you have a circle and another circle. This would be that piece that's right in there. One event happens and the other one happens. So if you want to know your multiplication rule, we're going to write it like this. The probability that A and B both happen is probability of A multiplied by the probability of B. Now, in future chapters, we'll talk about when this does and doesn't work, but for right now, we're going to keep it simple. So find the probability of the first event, find the probability of the second, multiply. Up here, I gave you kind of a tough problem that involved combinations. This was yesterday's video. It was tough. But if we wanted a different way to do it, a little bit easier, let's think about it. So what's the probability that you have 2 milk chocolates? Well, the first time that you choose one, there's 4 out of 12. So it'd be a 4/12 probability. Well, assuming you eat that chocolate right away, the second time you'll have only 3 left because you already ate one out of possible 11 because you already ate one. And you could just find the probability 1, probability 2, and you can multiply them. So if we go on here, we get 4 divided by 12 times 3 divided by 11, and you get that decimal, math, and frac, and we get 1/11th, and that is the same probability we had. So a different way to do it. All right, let's talk a little bit about blood types. According to the American Red Cross, the distribution of blood types in the U.S. is roughly as follows. So 45% have type O, 40% type A, 11% type B, and 4% with AB. Let's say we just pick 2 random people. What's the probability that both have type O? Well, the probability the first one does is 0.45. The probability the second one does is 0.45. So if you want something followed by the other, so this one and that one, we're just going to multiply. So you go 0.45, square it, and you get a 20.25% chance. Well, neither has type A. Let's talk about that. Well, what's the probability the first one does not have type A? Well, the probability they do is 40, so the probability they don't is going to be adding up the rest of these, or just using 100 minus 40 is going to be 60. It's 0.6. So if the first one does not, there's a 60% chance. The second one does not, there's a 60% chance. So we can just go 0.6 times 0.6 and get a 36% chance that neither has type A. Last one that got left off here, the probability that they have the same. Okay, well, there's actually 4 different ways that can happen. The first way is if you get a 0.45 and another 0.45. That would be two people who both have type O. The second way that this could happen is to have a 0.4 followed by another 0.4. So they both have type A. The third way that this can happen is a 0.11 followed by a 0.11, and then the last one is obviously a 0.04 followed by a 0.04. So these are all the different ways that you can have people with the same blood types. Take those probabilities and add them up, and you're going to have your total probability. So I'm just going to use squared for each one to make it a little quicker. 0.45 squared plus, let's say 0.4 squared plus 0.11 squared plus 0.04 squared. And you've got a 37.62% chance that you find two people who have the same blood type right in a row. All right, on to page 3. Little discussion here. At South Christian, 27% of the student body is on the cross-country team, at least it feels that way anyways, and 80% of the student body has a GPA over 3. Is this possible? I mean, if you add up those two probabilities, that's more than 100%, so you can't do that, right? Well, hopefully we're obviously catching on to, yeah, it's possible, because there's people who are both on the cross-country team, and they also have a high GPA. So, yeah, that does happen. If these events were mutually exclusive, that would mean you have one group of people here, your cross-country people, and you'd have another group of people over here, your smart GPA people with a high GPA. Mutually exclusive means there's nobody in the intersection. There's nobody who's doing both things at the same time. Okay? So this would be impossible because you have 27% and 80%, so these cannot be mutually exclusive events. If these were, if this is possible, and it is, it goes like this. You'll have one group of people, your cross-country people, and you'd also have your other group of people, your smart people, your GPA people over here. And in here, you're going to have some section of people who do both things, have a high GPA and run on the cross-country team. All right, that was, excuse me, that was part 1 where we're going to talk about and, two events happening. Now we're going to talk about or. What's the probability that one or the other thing happens? Now, first of all, we have to know that in math you talk about the word or a little differently. Like in English, if you say one or the other, it means you got to pick between the two. In math, if we say one or the other, that means that either one could happen and that would be fine. So here's what I mean before we get into the formula. What's the probability of rolling two dice and getting a sum of 6 or 7? Well, if you say you have to do one or the other, well, that doesn't make sense. But in math, that means if it does the first one, great. If it does the second one, great. We're gonna take those two probabilities and put them together. So let's take the probability of getting the sum of a 6. So if I go on my paper and put it right here, the sum of a 6, they work in diagonals here. There's going to be 1, 2, 3, 4, 5 ways. So there's a 5/36 chance that the first event happens. And then now, let's talk about a sum of a 7. That's the second one. There looks like there's 1, 2, 3, 4, 5, 6. There's 6/36. So we're going to say the probability that you get one or the other, not having to choose between, doesn't matter which one, is going to be the addition of those two, which is 11/36. So you can just take them and add them up. But there is one little sneaky part about this, and let's talk about example 7 here for a second. So what is the probability of rolling 2 dice and getting either doubles, or a sum of 10? You're doing one or the other. Well, let's find the first event. Doubles would be right in here, and I'm going to box them up on here. I don't know if I'd write on your dice paper, but I'm going to. So we got 1, 2, 3, 4, 5, and 6. So doubles, oh, easy, 6 out of 36. Plus, now let's do the sum of 10. And I'll take my little highlighter here, and I'll highlight them up. Sum of 10s right here. There's 1, 2, 3. So there's 3 of them. I might just add up now. 3/36. And the answer is 9/36. Well, actually, hold on one sec, because let's review our counting 1 second. I started to count them up. It'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. But ooh, look, I accidentally counted 1 twice. And you don't want to do that. As I'm counting them up, your actual answer is 1, 2, 3, 4, 5, 6, 7, 8 of them. It's actually 836, and we'll reduce that fraction in a second. So you have to be careful. Some of these lie in what we call the intersection. They lie in group 1 and they lie in group 2. And you have to make sure that you don't count them twice. So you count them once, count them twice, and then subtract the number that are in both groups. So it would actually go like this. It would say the first group has 636, the second group has 336, and then there's actually 136 that's in both. So you're going to add them up and then subtract what we call the intersection. Okay, so your actual answer here is going to be 836, which if you cancel a 4 is what, 2 ninths? All right, so your math goes like this. The word or, we're going to use a U like that, and we're going to call it the union, the joining of two of them. If you're going to have your intersection, your Venn diagram with an intersection, it's going to look like this. Here's group 1, we're going to shade it in. Here's group 2, we're going to shade it in. It has to be in one group or the other, but be oh so careful not to color, not to count that same group 2 times. It looks like this. The probability of one event or another happen, A, U, B, is this. The probability of the first event plus the probability of the second event minus the probability of both events. And we're going to call that P, A intersect B. Kind of went outside my box there. So add them up and subtract the ones that are in the intersection. Okay, so let's see. At South Christian, we're going to say 90% of the student body has a cell phone, probably higher than that. 60% have an iPod. What's the probability if we randomly select a student that they have a cell phone or an iPod, one or the other? Well, I'll do it using the formula in just a sec, but the best way for sure to do this is with a Venn diagram. We're going to draw a box here. In one group, we're going to have our cell phone people over here. And we're going to have these intersect because we know that there's people with cell phones and iPods out there. Cell phone and an iPod. We're going to start out with the intersection. What's the probability a random selected person would do both? Well, the way that you find both, we said at the first one, is to multiply probabilities, assuming these are independent events, and that's actually a conversation for later this week. But 0.9 times 0.6 is a 54% chance. So we have 0.54 is going to go right in the middle. That's the probability you get someone with both. Well, we know that for the cell phone people, the total sum has to be 90%. So 54% is already in this little sliver. This whole circle has to account for 90%. So hopefully it's clear this needs to be a 0.36. So that when I add up all my cell phone people, all this should add up to 0.9 together. When I add up iPod people, this should be, over here, should just be 0.06. So if I want to say what this is, to make sure this circle completely adds up to 60%. So if I wanted to say what this means, these people in the middle have both. These people right here have just a cell phone but not an iPod. These people have an iPod but not a cell phone. Another number that's handy to put in is the people that have none. So let's answer the question, what's the probability someone has a cell phone or an iPod, one or the other? And remember, the way that we use this in math means you do not have to pick between the two. You can have one, you can have the other, you can have both. That's fine. We use it a little bit differently. So one or the other means I'm going to take these three numbers and I'm going to add them up. 0.36 plus 0.54 plus 0.06, and I'm going to have 0.96. So there is a 96% of the people have a cell phone or an iPod or both. A handy number to put in here is down here in the corner is this 0.04, and this 0.04 represents the people that have neither. It's a handy number to know. All right, if I wanted to use the formula for this, here's what I would do. If I want to use the OR formula, you take your two things and you add them up. You go 0.9 plus 0.6. So you add up your two probabilities, and then you subtract the intersection, which is 0.54. Or very specifically, if I want to do this, I'm going to go 0.9 plus 0.6 minus 0.9 times 0.6. So you're going to add them up. for 150% and then subtract the 54 to get your 0.96. So once you have the picture drawn, this is really the best way to solve it. Then you'll have, what's the probability that a randomly selected person will have a cell phone or an iPod, but not both? Well, cell phone or an iPod, but not both would be this one. We'll take those numbers and put them together. So we'll have one or the other, but not both. We can just add this number and this number together for a 42% chance. All right, last question. Quick one. 13 of the 50 states include a territory that lies west of the Continental Divide. 42 states include territory that lies east of the Continental Divide. Is this possible? Well, the reason maybe not is because there's 42 here and there's 13. Well, 42 and 13, that makes, what would that make, 55? So that's not possible. Hopefully it's clear. Add them up and you'll get 55. So you'll have, yes, it's possible because 5 states have territory on both sides. All right, that's it.